Okay.
The little scrolly thingy on the right is kind of short.
I'll say no.
All right. Just to give the visual from yesterday, because since we were pushing it toward the end and Algebra 1 was coming in and getting a little antsy, just a little bit of what this graph would have looked like. And then the point that we were looking at are these 2 points here where it turned around.
So that's just a visual there. Okay.
It's an approximate visual. It's not anything perfect by any means.
So it's a visual-ish.
Yeah.
Gotcha.
All right. So that was all case 1. We are now on to case 2. This color looks fun. Case 2.
Funsies.
Functions whose derivatives may not exist everywhere.
Why did you write it in Roman numerals?
Is that not what I did with the first one? Everywhere's.
I don't think so. I think you just wrote a line.
Would it make you happy if I changed it to a number 2 instead?
Yeah, it would.
So if there are values of x of which a first or second derivative does not exist, consider the values separately. Recall a local max or min is one of transition. Between intervals of rise and fall and an inflection point is one of transition between intervals of upward and downward concavity. Wow. Some insane rain right there.
Glad I didn't have to bring in the poster in that. Oh no.
I was trying to see what I did earlier when I did the example yesterday. Because I'm going to do 2 different examples here.
I can't tell how much of that sound is just the air blowing in here and how much of it is the rain outside.
I'm pretty sure it's all the rain. A little bit of it's the air. But most of it's the rain.
Virginia, do you have a headache today?
Actually, no. That is because I drank an energy drink.
No.
Yeah, a little bit.
No.
Well, usually if you have a headache, like a day, like it's rained, you don't usually get it back-to-back days because like I don't have one today either, and I had one the other day.
Well, Virginia, you should probably
Because
drink
I had
water.
one yesterday.
You should drink water.
I have been drinking water.
Yeah, maybe that's why you don't have a headache.
No, but I mean, I have drinking more than usual.
You should drink more than usual. Make out your usual. Do better, Virginia.
All right, so we're gonna try to demonstrate case 2 here, and then I'm gonna do another example separate from this that shows all the steps where we need to do step 4 instead of just skipping step 5. So, we need to find the first and second derivative. So, what would the first derivative of this be?
There's x to the
And I could rewrite this as 2 over 3x to the 1/3 like that. Which I'm going to leave it the other way for the sake of finding the second derivative, but the technical correct way to write y prime would be the bottom. And y double prime would be what?
negative 2 9x to the
You got this.
negative 1 1/3.
Okay, so
Don't
negative
you
4/3.
Okay.
You don't do mixed numbers.
I've been trying to train algebra 1 that like we don't use mixed numbers. I'm like, leave it improper. I'm like, or if you're gonna do anything, change it to a decimal, but do not give me a mixed number. And they're like, we're allowed to do that? I'm like, oh my goodness, I've been telling you since week 1 of school to leave them that way. I was like, ah.
So why did they teach us how to do mixed numbers if we're only going to end up?
It's the same way that they didn't teach you PEMDAS until you learned that you just do left to right on everything, and now that's why the world thinks that a problem that's super simple, that the answer is 16, that the answer is 1 because they don't understand rules of operations. It's fine. It
Note
is
to self, make sure you teach your children PEMDAS because the school won't.
Well, they will, but the problem is if you teach your kid PEMDAS and they're like in lower elementary school, they're going to get everything wrong.
Yeah.
Because they're just supposed to do it as a sequence. Like, you
Well,
probably
teach
did in
them what we
elementary,
said
they would
that
do
day.
like competitions where they'd have like 2 people go up and they would like say a number. They'd be like 8 plus 4 minus 2 divided by 3. And like then they would be like, what's the answer? Like, you know, or they'd be like, answer. And you had to like turn really quick and give the answer. Well, because they taught you to do it that way. But order of operations would not tell you to do it that way.
Right.
So.
So that's why I would tell my child that. So this is how you're actually supposed to do this, but they're going to want you to go from left to right, so just do what they say, even though you know it's wrong.
Josh would tell the teacher the kid's not allowed to do flashcards. Like, I'm sorry. We have notes.
All right, so is there any way that either of these derivatives is equal to 0?
I don't think so.
Correct, because the top is never going to be 0, which would be the only way for it to be 0. So neither derivative is 0. Because both derivatives fail to exist, or we would say D and E, when x equals 0. All right, so then we want to look at the sign of y prime to determine basically if we're going to have a min or a max. So as x increases, I'm going to do this until we have all the things. As x increases through 0, y prime changes from, so if I put in, say, -1 to y prime for x, what do I get? So it would be negative. What do you get when you plug in a +1?
Positive.
So it changes from negative to positive. So 0, 0 is a min. Because if I plugged in 0 to x in the original, we would get a y value of 0. So an x is 0, y is 0. So that's why this is the original point, if you remember from yesterday. So then we need to also look at y double prime. So what happens if I put in a -1 in y double prime?
Positive. Oh. Negative. Wait.
It would be -2/9, right? -1 raised to the 4th, and then would become positive. And then, so it'd be -2/9. What if I put in 1?
Still
-2/9. So it remains negative the whole way through. So y double prime is negative everywhere except when, or except at 0. So the curve is concave down. Like missed the letters in the middle. Then it looked weird.
Yeah, if you had listened to the notes, you would have heard a conversation about convexity.
Convexity.
But since you didn't listen to the notes, you'll never know about convexity.
So just so you know, this original graph would have looked kind of like a bird.
Birds.
We would have had points here and here. All right, one more example where we actually need step 4, because yesterday in the one that I did, step 4 was unnecessary. In this one, we are going to need a step 4. So f of x equals x to the 4th minus 4x cubed. Just like peachy color. All right, so step 1. We find y prime and y double prime. What is y prime?
4x to the 3rd minus 12x squared.
Yep. And what about y double prime?
12x squared minus 24x.
Beautiful. So now we take the first derivative and we set it equal to 0. That would be step 2. So we would do 4x cubed minus 12x squared is equal to 0. How do I solve? Basic
So
algebra now.
we can pull out a 4x squared.
Yep. And that leaves me with x minus 3. So x equals what?
0 and 3.
So these are the 2 points that I'm going to be looking at. Now, step 3, just to make sure, where is it? Come on. Where did you go? Step 3 is we're going to use the numbers that we had found here, and we are going to plug those into the second derivative and see what the sign of the second derivative is. Okay, so this was, step 2 was where y prime is equal to 0. Step 3 is going to be where y double prime of the value that we found, and we're going to be determining if it's greater than or less than 0, basically. So, f double prime, or I guess I should say y double prime since that's what I've been using. Something just erased itself, I think, that I had written. Nope, nothing else did. Okay. Just being weird. Alright, y double prime, or well, I'm going to use f because I want to be able to show what value I'm plugging in. Sorry, I keep mixing up and changing my mind. I'm going to start with 3 for the sake of what I want to show you. Normally I would do them in order, but so f double prime of 3, I'm plugging in 3 to the second derivative, so 12 times 3 squared minus 24 times 3. And that will give me 36. So that tells me that f double prime of 3 is greater than 0. If it's greater than, then we have a min, so it's opposite technically of what you would typically think. Greater than, usually you would think max, but it's min. So they're opposite. So we want to say where that minimum occurs, because a lot of the questions, especially in the book, are going to say, like, tell if it's like the points are a min or a max and tell where they occur. So this min is at 3, and then f of 3, which is 3, and if I plug in 3 to the original, I'm going to go up here and do it. F of 3 is 3 to the 4th minus 4 times 3 cubed, which gives us a negative 27. So 3 and negative 27 is where the min occurs. Normally I won't write f of 3 here. I'm just doing this for a visual for when you go back to see what that value was.
What did you plug 3 into? Oh.
The original.
Okay.
Yeah. Which is also why I'm using this notation, the f of 3, so that you can see what it is. So now I've checked 3, I need to check 0. As many zeros as you get in step 2, you have to check all of them. Because obviously it can keep, a graph could keep turning around. So then I'm going to do f double prime, of 0. So if I plug in 0 to the second derivative, I'm going to have 12 times 0 squared minus 24 times 0, which is what? 0. So the second derivative test fails. Meaning I need step 4. So now I'm looking for if the derivative changes sign as we go from negative to positive, basically, across, as we go from, like, going through that point. So I want to know what the first derivative does as I go through the point 0. So if I plug in negative 1 to the first derivative, what do I get?
-16.
Okay. And if I plug in positive 1, what do I get?
-8.
Okay, so both of these are negative, which was kind of like the example we had previously. So f prime of x does not change sign. As x increases through 0. So 0, 0 is neither a min or max. So in the previous example, it changed from negative to positive, so it was a min. This one does not change, so this one is neither.
So if it goes positive, then it's a.
So if it goes positive to negative, it would be a max.
Okay.
So you can kind of think like if you were looking at a graph, it's like legitimately dark outside.
But it's not really raining.
It looks like it's like after.
I know.
It is actually.
It's weird.
Well, like,
It's
I think it is
entire
raining. I
hour
think it's just
before.
really hard to see because it's so dark outside.
Oh yeah, you're right. It is raining.
yeah.
But you mean it's a whole hour and 4 minutes
Oh.
and almost 30 seconds actually.
But you can kind of think like if it's going, I'm going to try to do it facing you. If it's like increasing, so if it's like positive and then it starts going negative, you can think of it like a parabola. But if it's like negative and then it's positive, again, you can think of it like a parabola. So that can help you kind of visually see if it's a min or a max, which is pretty much what I do. I'm sure there's some official mathematical way to think about it, but that's what I do.
Also, do you have a charger like for an iPad?
Is it USB-C or the other one? Yes, it's just not super, super strong.
Okay. It's at 5.
We only have one step of this left if you want to just finish it and then
I
do
think
that.
that's good.
But yes, you can use it. That's fine.
Thank you.
All right, so step 5, we now look at find all x values where f double prime equals 0. These are possible points of inflection, so we're going to check to see if they are. So f double prime is 12x squared minus 24x equals 0. Factor out the 12x. I'm left with x minus 2. So where is x 0?
At 0 and 2.
Yep. I guess you say where's the function 0? Wording. All right, so now we're looking at if c is an x and the sign of y prime changes from either positive to negative or negative to positive as x increases through c, then c is the x coordinate of a point of inflection. If the sign does not change, it is not a point of inflection. So we want to see if the sign of the second derivative changes. That was weird. As x increases. So as we increase through 0, so if I go like negative to positive, if I put in a negative number here like negative 1, what happens?
Positive.
It's positive. What if I put in a positive number like positive 1?
Negative.
Negative. So that goes positive to negative. So the sign changes as x increases through 0 from positive to negative. And through 2, we want to do the same thing. So let's say 1, we already said was negative. If I plug in 3, positive. So that one changes from negative to positive. So both are going to be points of inflection. So f double prime, this is the last thing, changes sign as x increases through 0. It goes from positive to negative. And x increases through 2. Or I guess to say as x increases through 2. It goes from negative to positive. So the point 0, 0, and this is getting plugged into the original. And 2, if I plug in 2 to the original, 2 to the 4th is 16 minus 4 times 8 is 32, so 16 minus 32 would be negative 16. So 2, negative 16 are points of inflection. And I'm just going to make a note here from the original. Confirm. And finally, we are done with all the notes for 5.1. But you see why we went ahead and did these now versus when you come back from break.